In this video, we're going to take a look at some more questions about transformations of rational functions. So let's take a look at number 1 on page 19. Number 1 says f of x equals 1 over x minus 5, and we want to state the transformations, the vertical asymptote, the horizontal asymptote, and then sketch our graph. So what we can do by just looking at this function is we can pick out the vertical asymptote because we know that goes with the restrictions that we've been picking out throughout this unit. So if x is not equal to 5 because it would make our denominator equal to 0, that is automatically our vertical asymptote at x equals 5. The horizontal asymptote goes with the k value that would be out back of our function, like not in a grouping symbol, but when it's not there, it's just 0. So in this case, y would just equal 0. And then in this function, we don't have an a value other than 1, so we don't have a vertical stretch or compression, and then the function is not negative, so it doesn't reflect over the x-axis either. So all we can say about this function is since the vertical asymptote is at 5, and it's in our grouping symbol, it went right 5. It shifted to the right 5, because in this case, our grouping symbol is in the denominator. So now let's just sketch it. We have a vertical asymptote at x equals 5. So 1, 2, 3, 4, 5. The horizontal is at 0. So that is just the x-axis. And then it's positive. So that means our function is going to be in this first sort of quadrant looking space, but not touching the asymptotes. And then in the third. If we consider these sort of like our quadrants, then when it's positive, it should go in the first and the third. And then you can always type it in Desmos to make sure you've got it in the right place. And we have no holes in the graph, so we're good so far. Let's take a look at another one. So number 3 has 2 over x plus 1 minus 3. So the first thing I can do is look at the denominator, and I can say that this function is going to shift left 1. And that means it's going to have a vertical asymptote at x equals 1. The horizontal asymptote is going to go with the minus 3. So that means it's going to go, let me write it over here, down 3. And it's going to be at x equals negative, or excuse me, y equals negative 3. X is the vertical. Okay. Then we also have an a value of 2. So the 2 is larger than 1, so it's going to make our function have a vertical stretch by a factor of 2. Okay, so let's sketch it. We have a vertical asymptote at 1, or excuse me, negative 1, because that's our restricted value. So go to negative 1, because it went left 1. That's also why it should be a negative 1. And sketch the vertical asymptote. The y equals negative 3 is our horizontal. So let's sketch that right there. It's hard to really sketch the fact that it has a stretch of 2 because these already look stretched out. But since it's a positive, because we don't see a negative in the front, it should still go in like the first and third. They're not quadrants, but you can kind of relate them to our quadrants. And then that's it for number 3. All right, let's look at number 5. We have x minus 2 in the denominator, which is going to make it shift right 2. And then that's going to make it have a vertical asymptote at x equals 2. Those are paired together. The positive 2 in the back makes it shift up 2 because that's not in the grouping symbol, which will be y equals 2. And then our a value is just 1, so we don't have a vertical stretch or compression, and it's not a negative. So let's graph our vertical asymptote at right 2, or x equals 2. Then the horizontal is also at 2, so y equals 2. And always make those dashed lines because they're not really part of your graph, but they definitely guide where your graph should go. And then it's positive, so it should go here in this little quadrant area and right here, but never crossing over the asymptotes. Okay, so that's it for that one. Now we've done a few of these. So let's look at one of them that's negative. Let's look at number 8. Even though it's even, that's okay. So x minus 3 is in our denominator. That's going to make our graph shift to the right 3. And so we're going to have a vertical asymptote at x equals 3. We have no value for k, so that just means it's 0. So our horizontal asymptote would be y equals 0. Our a value is negative and it's equal to 2, which are two different transformations. They both deal with the same number, so I know that gets confusing. But it's going to reflect over the x-axis because it's negative, but it's also going to have a vertical stretch of 2 because it's greater than 1. So let's write vertical stretch by a factor of 2. And it's good to be able to pick those out of your function because it's actually hard to see even in Desmos because they already look stretched. So let's go to x equals 3 and sketch the vertical asymptote at 3. Because it shifted to the right 3. Then the horizontal is at 0, so that's the x-axis. And then this one reflected over the x-axis. So instead of going in this area and in this area, it reflected, so it should go in like the 2nd and 4th quadrant. And I am sketching these by knowing that rule that that's where they go. But you can certainly always type them in Desmos if you want to be on the safe side. So I always recommend you type in the original function. So let me just show you that one more time. Just make sure like x minus 3 is all in the denominator. Let's see how it does end up in those places right there. But if I took away the negative, then it's in the sort of 1st and 3rd quadrant. So that shows you what that negative is doing. Okay, let's look at a few on the next page. This just wants you to pick them out. So you're not having to graph anything, you're only picking them out. So for the horizontal asymptote, you can look at the degree of the numerator compared to the degree of the denominator. And you can also look for that k value we were just looking for. So I don't see a k value, so that's just 0. But it's also 0 because the degree in the denominator is greater than the degree in the numerator. So that's another way to look at it. So let's look at number 9. In this case, I can see that the degree in the numerator and the degree in the denominator are the same. So I need to pick out the a over b, which is the leading coefficient of the numerator over the leading coefficient of the denominator. So in this case, it would be y equals 1/2 because the degree of the denominator equals the degree of the numerator. All right, let's see. Let's pick out, let's do number 11. In this case, we have the degree of the denominator is larger than the degree of the numerator. And so in that case, y just equals 0. So that's all you're doing for this part is just picking them out. You can also type them in Desmos and look and make sure that these numbers make sense. So let me just show you real quick. Like on number 9, since that one was kind of different, it had a 1/2. Sorry, my desk keeps squeaking when I move. So, excuse me, x plus 3 over, and then we had a 2 out front. So let me put the 2. And then x plus 4. And you can see it's just a little bit above 0. So just type in y equals 1/2 or 0.5. And you can check and make sure it makes sense. So that's a great way to check it and make sure you got it right. Now let's look at the vertical asymptotes. So on these, you want to also make sure that you cancel out any holes in the graph like we've been talking about. So in this case, on number 13, I have a hole that would occur at x equals 2 because x minus 2 would cancel out. So before I pick out a vertical asymptote, double check that you don't have any holes in the graph. So I had to simplify it a little bit first. And then what's left after you have a hole at x equals 2, that's what that would mean. Then I can look at where is this denominator restricted, and it would be restricted at x equals -2 because -2 plus 2 would give me 0, and that is not allowed. So the vertical asymptote is at that restricted value. So it would be x equals -2. let's see, number 15, we just want to focus on, does it have any holes, and what would the denominator be that's left over? So in our numerator, we have a perfect square with x squared, and we have a difference, but then 2 is not a perfect square. So we can't factor anything out. We can look at the denominator and see that x cannot equal -2. So we just have a vertical asymptote at x equals -2. And then in number 17, let's look at one more. We have 2 vertical asymptotes because nothing cancels out, so we don't have any holes in the graph. We would just have 5x plus 4 is restricted at 0. In other words, it can't equal 0. And x minus 3 also is restricted at 0. So if we set up these equations, we can just figure out our vertical asymptote by solving them. So 5x equals -4 and divide by 5. So in other words, x can't equal -4/5. So that is one of our vertical asymptotes. And you can also write it as a decimal, which should be -0.8. Either way is fine. And then for the other one, if we add 3, or some of you just look at that and know that the restriction is at 3, and you don't have to use the whole equation. But we just have 2 vertical asymptotes for this problem, and that can happen. So x equals -4/5 or -0.8 and x equals 3 are both vertical asymptotes. So that should be enough to get you started on this practice.